So now let's talk about something called class-full IP addressing. When we get to the end of this lesson, we'll talk about this right here, this class-full IP addressing versus classless interdomain routing. Okay, but before we get to that, let's just start off by learning about class-full IP addressing. Because originally, IP addresses were divided into just these different class ranges. We had our A class of IP addresses, where the first octet was the network ID, and the last three octets were all host ID. That's why I have a subnet mask listed there of 255.0.0.0. What I can tell you that goes beyond that is that you will recognize one of these Class A IP addresses because the first octet, the first number in the IP address, will be anywhere from 1 to 126. Now, again, there is a binary reason for the numbers 1 to 126, but don't worry about it for right now. For right now, just I have a chart in front of you. We have the B class range of IP addresses, and you can recognize them because the first number, the first octet in the IP address, will be 128 to 191, which, by the way, you notice there's a number missing there. A class ends with 126, B class starts with 128. Yeah, the number that's missing is 127, the one I told you that was reserved for diagnostic, right? So 128 to 191 would be the first octet, but in a B class IP address, the first two octets make up the network ID, and the last two octets make up the host ID. We then had the Class C range of IP addresses, where the first octet starts with 192 to 223, and with our Class C IP addresses, the first three octets make up the network ID, and the last octet all by itself would be the host ID. We had a Class D range of IP addresses, 224 to 239, which were reserved. And I shouldn't even say were. I'm talking like this is past tense. It kind of is in the way we think today because we don't really too heavily go out and work with these days. But technically, this is still used. Okay, so even though you've heard me say like were or make it sound like past tense, it is technically still current. But the Class D range of IP addresses are reserved for multicast communications. Again, in a previous lesson, talked about multicast communication where you have one sender and multiple recipients, and they have to subscribe to a multicast range, and that's what we have here is those Class D addresses. Very often you'll see that a computer, when it's participating in a multicast transmission, it'll have an IP address starting with 224. And then we even move into a Class E range, which starts with 240 to 243, and that's reserved for experimental. So really what you need to pay attention to here is Class A, B, and C. Okay, those are the only IP addresses that could actually be assigned to hosts. Now in the A class, we have 126 networks. Why is that? Well, because it's the networks that start with 1 to 126, and only the first octet is the network ID, so it can only be those 126 networks. But since the last three octets all make up the host ID, if you did the math, and I will tell you, there is some math to be done, and the simple way of doing it would be basically to say that you can have 256 numbers, right? The numbers 0 to 255, so a total of 256 possible numbers in each of the last three octets. 256 times 256 times 256, and then technically you have to say minus 2, right? Because we can't have all zeros and we can't have all 255s. That gives us 16,777,214 hosts within one of those A class networks. That's a pretty big network, huh? Yeah, it sure is. And we're going to see how it's because of a large network like that that really nobody can fill, that we had a lot of wasted IP addresses. And then we'll talk about how we fix that. The Class B networks, we actually have 16,384. Now, I know you might be thinking, wait a minute, that seems like a big number. You said it was just IP addresses that start with 128 up to 191. Well, the reason it's more than just another what would that be? Or around 64 networks or so, is because yeah, the first octet maybe can only be those 60 some odd numbers, but then you have the second octet, which you still have 256 choices. So you end up, if you do the math, being able to have 16,384 B class networks out there, and each of those networks have 65,534 hosts. Again, taking the last two octets, 256 times 256 minus 2, it's always minus 2, you get the 65,000 hosts. And then you have your Class C networks, and there are actually just a little bit over 2 million of those networks available, but each of those networks can only have 254 hosts. If you do all this math and you add it all together, and by the way, don't worry about the math here. This is not the math lesson. But if you were to add it all together, you'd end up with a total of approximately 3,720,314,628. Now you notice I said approximate and then I gave you an exact number, right? So you had just a little bit under 4 billion IP addresses available. And that sure seems like it should be enough, right? I mean that's a big number, 4 billion. Well, we did actually eventually run out. And again, I'm going to explain to you how we dealt with the fact that there's really nobody out there that can fill the 17 million hosts that are on a Class A network. And then also how we dealt with the fact that we now have more than 4 billion hosts. So how are we still using IP addressing the way it's listed here? Yeah, there's actually, I'll jump ahead and I'll tell you there's a technology called NAT, Network Address Translation, that helps us with all this.